Good morning, Honors Algebra 2. It is April 1st, and we're into our third day of online learning. So let's go ahead and talk today about how we can find the area of triangles if we don't know the height, which is defined to be the perpendicular distance from the base to the apex of the triangle. Now we know our old area formula is area equals 1/2 base times height. And you say to yourself, what's this K doing here? Well, I'll tell you what this K is doing here. We're going to substitute a K for area because in all of our trig triangles, we have an A, capital A for angle A. So it gets a little confusing. Now, we're going to use three different formulas, and they are found in your book on page 597. And you're going to have everything open book, so you're not going to have to memorize anything here. So you just need to understand how to apply them. So the first one is what we'll use when we have our friend side, angle, side. Side, angle, side. Two sides with an angle in between. Okay, so remember that would be like side C, angle B, side A. Alrighty. Now, what we'll use here is this formula. The area can be 1/2 side B, side C times sine of angle A. Okay, remember we've got a B, a C, and then an A here. Remember, so we can always tell it's SAS. Or you could substitute in 1/2 AC sine B. Notice all letters are represented. Or finally, 1/2 AB sine C. All right, that's for your SAS scenario. You can use that formula. We're not going to derive it. That can be for a later, more advanced class. We're just going to understand them and embrace them. Okay, let's go to what do we do if we know all three sides? Okay, so what we do here is we use this formula. The book says it's Hero's formula. I've heard more Heron's formula. But anyway, it is the square root. The area of a triangle, if you know all three sides, is S, we'll define that in a second, times S minus side A, times S minus side B, times S minus side C. The square root of all that. Sorry, I'm in the glare zone right there. And what is S defined to be? Half of the perimeter of the triangle. Half of the perimeter of the triangle. So that's a real straightforward one. You know all three sides, you use this formula. Now let's finally go to what do we use when we have two angles in one side. Now, we could call that angle side, alrighty? So we could have two angles and a non-included side, like angle C, angle B, and then side C. Or angle side angle would be having an angle, its included side, and then another angle. But any way you slice it, anytime you have two angles and a side length, you can use this formula. Now, it is 1/2 A squared, and then all of the angles are represented here, sine B, sine C over sine A. And you say, well, I only have two angles. Well, anytime you have two angles in a triangle, we can always find the third angle, so that's no big deal. And then we can substitute in here B squared, and then the sine B goes down below the denominator, and sine A, sine C are up the top. Or you can have 1/2 C squared, and then the sine of angle C goes in the denominator, and sine A, sine B in the numerator. So those are just your straight up formulas. Let's go ahead and apply those. Is this not your favorite part? This is my favorite part. Okay, here we go. Now, let's look at our first example over here. We have an angle, and then a side, and then an angle. We have ASA. And so we have two angles, so we can use the third formula in your list there. And we have to know all three angles. No big deal. This angle is 65, this one's 100. Subtract that sum from 180, and you get the remaining angle is a little bitty 15-degree angle. Now, how do we know what goes where? Well, we know this side down here is 2.2. And so that's going to be my C squared. And you can make it an A squared, whatever you want it to be. But it's C squared here. Is just the example I'm going to go ahead and give. And so I'm going to define this side to be C squared. So this angle will be angle C, opposite. So that's why I put sine 15 degrees. C is here. It doesn't really matter which one of these you define to be A and B. You can plug in 65 and 100. It's not going to matter one bit. They're just going to be your two angles in the numerator. And it's a crunch problem. Please be careful. It will ask you, I believe, most of the time in the homework to do three significant figures. So let's be careful with that. That is an 8 point, I noticed my decimal point doesn't show up too well in these videos, 8.35 meters squared. There we go. Okay, now, side, side, side. We know we use the law of cosines for that one, but now we're finding area, and so we're going to use the formula with the square root. First, we're going to go ahead and find the perimeter and take half of it to define s, and then we will put s in the square root, so the square root of s times s minus the first side times s minus the second side times s minus the third side length, and here I get 1498. But only 3 sig figs are allowed. Well, you can't do 1490, can you? You've got to bump this up. Well, 98 goes up to, it's going to bump up for 3 sig figs. That 9 is going to have to make it up into a 1500. There's no way to leave it as a 149, and so you got to go up to 150 and stick on a 0 on the end. And I've got the units or feet squared because I had units here. Now, let's go to the bad boy over here. The bad boy over here is, oh yes, he has returned. We have side, side, angle, not included angle. Oh, it's our friend SSA from yesterday. And it's the exact same triangle we actually used in our example. Now, we didn't talk about SSA as one of our formulas. We only talked about if you know one angle, that we use that first formula, and that was the SAS. So what we've got to do here, we don't have all 3 sides. We could find those, but we're going to go ahead. We have an angle. We have 2 sides, but the angle that we have is not an included angle. But I have these 2 sides here. If I could find the measurement of angle A, I would have side, angle, side. And so I'm just one step away from having the information to use this formula, the first formula, the SAS formula. So let's go ahead and turn this SSA into an SAS. In order to do that, I've got to find the measure of angle A, but I know that my given angle's opposite side is 22 and it's shorter than 30. And so I have the swinging side here. I have 2 triangle options. Angle C could be acute or it could be obtuse. So what we use is we have an angle and its opposite side, so let's use the law of sines. The sine of 30 degrees over 22 equals the sine of C over 30. And remember, we got angle C to be 43 degrees. But you can also have this supplementary angle here could be your value for angle C also. So I'm going to do the supplement of 43 is 137. I have two values for angle C. And so then to find angle A, I'm first going to go with this choice here, the acute angle C. So then angle A would be 180 minus the sum of 43 and 30. And I get my angle A would be 107 degrees with this acute angle C. Now, what if C was the obtuse angle, 137? What if C is this angle right here? Well, that's going to change my value of A. A would be 180 minus the sum of 137 and 30, or it would be a little 13 degrees. So A could be obtuse, or it could be acute right here. Now, what does that mean? That means when I use my formula, I now have side, angle, side, but A has 2 options. A could be 107 or 13. So I'm going to go ahead and use my formula, BC sine A. And I have my B and my C, 22 and 30, and I have the included angle. Let's go ahead, we can fill in 107, or we could fill in 13. So I'm going to go ahead and crunch that out 2 different ways, and I could get to 3 sig figs. I could, if I have the obtuse value for angle A, I'm going to have 316 for my area. If I have the acute value for A, I'm going to have 74.3. And that makes sense, okay? If we have, this is obtuse, and we have this angle here, that's going to have a big area. If I use this scenario where C is obtuse, and this is my small angle, 13 degrees, I'm going to have a smaller area of just 74.3. So watch those sig figs and go ahead and do your assignment. You'll find it in RenWeb, and I'm going to check in the morning and see how you did on loading your assignment from last night. I'm going to be gracious if there was an issue, and we'll get it worked out. I will be messaging you tomorrow if I don't see your assignment in there. What else do I have to say? Oh, we're changing the Zoom formatting. Well, the ID basically. Talked to Mr. Bundy, and some people had some issues getting into Zoom in my meetings all day long. It was very difficult to get the invitation from LMS, excuse me. And so I've got one personal password. It's my Zoom ID password. I put it on the wall. I will have an open meeting. I'm going to open a meeting on my computer at 10 tomorrow morning. You have to just click on your Zoom app or your Zoom icon on your desktop and click join a meeting. And when you join a meeting, you'll enter in that ID that I posted on the wall, and you should be able to come right in. If you can't, go ahead and send me a chat, and we'll see if we can fix it. I hope we can. But I'm thinking Mr. Bundy and I practice. I think we're going to be in great shape. So y'all have a great day tomorrow, and find areas of those triangles. And I will see you on Thursday. Bye-bye.